Hi, folks, and today I'm going to be talking to you about binary conversions. Right here, we've got two different numbers, right? They look very different, right? One says 42, one says 101010. But I'm going to tell you they're the same numbers, represented in two different numbering systems. Now, the first system is the one you're probably very used to. This is base 10, also known as the decimal system. This is what you've grown up with. This is what you've been counting in since you were a small child. Unless you have like a really cool parent who taught you to count in binary when you were a kid. I'm trying to teach my niece. But this is the system you've always been used to, right? 42. That represents 42 different objects, or 42 different sticks, or whatever 42 things you want to count. But if we're looking at this number, this really is a 2 and a 4. And the way we get 42 out of that is that, well, we have 10 possible digits we can count from, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And at some point, right after 9, we run out of digits to keep counting up. So we need to start reusing them next to the other one. But we need to represent that that's a bigger amount, so we just know that the one over here is always worth 10. Have you ever wondered where that comes from? It comes from this, that 10 to the 0, well, that's just 1, because any number raised to the 0 is a 1. In our first digits place, it's just whatever's in that first digit times 1 is how many 1s we have. Now, in our next space, we've got 10 to the 1. This is our tens place. 10 to the 1 is 10, so we just have 10 times whatever's in that spot. You probably remember 95% of this, 99 or 100% of this from elementary school, right? Nothing I've talked about so far has been that complicated. All right, we make our number because, well, 4 times 10 plus 2 times 1 is equal to 40 plus 2, which is equal to 42. Right, that's how we get to 42 using our base 10 numbering system, right? It's kind of cyclical, right? We didn't really find out any extra information here, but we've at least talked about how our numbering system starts. It's great when you've got 10 different digits that you can count on. What if you're a computer, right? A computer doesn't have 10 possible options. A computer only has 0 or 1. It can either have a grounded state on a pin or it can have power on a pin. So in order to actually represent that in binary, we now need to just cut down the numbers that we're using, right? If we're trying to count to 42 in binary, well, then we go 0, 1. Oh, well, now I need to wrap around again and come back because I already overflowed. I can only count up to 1 before I need to go to the next column over. Now, since binary is base 2, there's only 2 possible options, off and on. We're just going to start out by putting in our bases here. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3, well, that's going to be 8. 2 to the 4, that's going to be 16. And 2 to the 5, well, that's going to be 32. Each time we're just counting up with the power that we're raising the base to. This works the same way as it would have in decimal, because we could have had 10 to the 2 here, and we just would have had 0, right? We could write a number out in decimal with a bunch of zeros in front of it forever. But we don't. That would be kind of pointless. It's the same reason in binary we don't carry the zeros out forever, right? We just go to the first one usually. Sometimes this will be represented a little bit differently because we'll put down 8 sets of 4. So we'll always have another 2 zeros here sometimes. That just has to do with programming more so. Now, in our binary system, right, we have our 1's place, our 2's place, our 4's place, our 8's place, our 16's place, and our 32's place. Now, the way we take a number out of binary and convert it into decimal is we're just going to take that number that's in binary right now, and we're just going to just multiply everything by its power here, and just follow it through and add them all together. I think you'll see what I mean. Right here we have a 0, so 0 times 1, well, that's 0. Now we're just going to keep adding all of these up. 1 times 2 plus 0 times 4 plus 1 times 8 plus 16 times 0 plus 32 times 1. That's going to give us 32 plus 8 plus 2. 32 plus 8 plus 2, that's 42. That's the decimal we started out with. That's the number in binary. Same number, two different ways to represent it. This is a pretty simple trick to convert from binary to decimal. This is the way most people will do it, actually, is they'll go through and they'll just kind of add up each one of those, the power of each one. Now, I'll have another video showing you how to convert from decimal into binary, but that's for another shot. All right, thanks for watching. I hope this was helpful.